Hello. In this lesson, we look at what we call frequency distributions in their graphs, and so we're looking at a form of descriptive statistics, what stories are told by tables and charts and what information we can pick up. So here's a lead-in idea. Let's say you work for a new company that develops GPS navigators for drones. You're asked to determine the price point for your system. What should you do to start? Well, the first thing you'd probably do is do a little market research and figure out the price points of your competitors. So you do some market research and you find the following price points. And the first thing you would probably look at is see what patterns you see. Why is it hard to detect them? Well, it's hard to detect them because this data set currently is very unorganized. So these types of questions, especially the patterns, are difficult to answer unless we systematically organize our information. We can do this using something called a frequency table. It's a way to group data into intervals or classes and count how many are at each level. It's similar to a bar graph. We will later call it a histogram, but that's what a frequency table is. So a frequency table, like we said, way to group data into intervals or classes and count how many are at each level. So a couple parts of a frequency table we should mention. When you group them into classes, there's something called the class width. The class width is the difference between the lower bounds, or you could use the higher bounds, between consecutive classes. In this case, 6 minus 1 would mean the class width is 5. We have the lower class limits and the upper class limits that set the boundaries for each interval. The frequency just tells us how many were at that level. So for example, for this item, there were 5 that were in between 1 and 5, whatever between 1 and 5 would mean. In our case, we're going to take the drone GPS price point and categorize it into a frequency table. The first thing that you need to do is determine your width. And how you determine your width is you do it using the following. First, you have to decide how many classes you would like, how many bars you would like in your bar graph, if you want to think about it that way. So that either needs to be provided to you, or you've kind of tried it around. If you do too few, it's hard to see any patterns because the groups are so large. If you do too many, again, it's so hard to tell because there might only be about one in each group. So there's kind of a Goldilocks zone. In this case, I'm going to say let's do 7 classes. So the first thing that you do is you got to calculate the width of each class. So what you do is you find the range. The range is the difference between the highest and the lowest value. The highest value in this data set is 450. The lowest value is 59. So I do 450 minus 59. That leaves me at 391. And I'm going to divide 391 by the number of classes, which is 7. I end up with 55.8. We'll call that 56. So I'm going to do widths of 56. Once I've done widths of 56 and I determine my width, I move on to step 2. I use my lower limit of 59, my class width of 56 to construct the 7 classes. So I start at 59, and I know if I add 56, I'm going to be at my new class level, its lower limit, which would be at 115. So I add 56. Then I add 56 to 115, and I'm going to get then to 171. And I just repeat this process, until I've done it and made my 7 classes. Now what I need to do is I need to go through the data and tally how many are in each class. This can become a meticulous item. That's why we will eventually use technology to do this, but we're going to do it by hand at first. So if you go through and tally it, you're going to see there are 5 that are in between 59 and 114. There are 8 that are in between 115 and 170. There are 6 in between 171 to 226, and then I'll just provide the rest to you for sake of time. But you would have to go through and you'd count those. So now I have my frequencies, how many occurred in each class level. Our next goal then is to construct a graph known as a frequency histogram. So a frequency histogram uses the frequency table to make a graph. It's the bar chart or bar graph. So a bar graph that represents the frequency distribution. The horizontal scale is the quantitative and measures the data values. The vertical scale measures the frequency of the classes. Consecutive bars are said to touch. So it's a nice grouping. When we're doing that, the numbers that separate classes without forming, in order to form, classes without forming gaps in between them, we use what are called, class boundaries. So the distance from the upper limit of the first class to the lower limit of the second class is 115 minus 114. If I subtract 1 and then I half that, I get 0.5. So what I can do is then I can subtract that from the lower limit, add it to the upper limit, and then my class levels will be what we call continuous. There won't be any gaps in between. So in our case, if we found our gaps in between each class is 1 divided by 2, we need to add a half to the upper limit, subtract a half from the lower limit. So my new class boundary for the first level would be 58.5 to 114.5. For this one, it would be 114.5 then to 170.5. Then I'd have 170.5 if I subtract 1 there, all the way up to 226.5, so that there's no gaps in between. Fill those in, and I've got all my following class boundaries. Now what I can do is I can graph it. So I'm going to plot my frequency histogram. So the first one is between 58.5 and 114.5, I need 5. So I go up here, and I'm going to have 5 that occurred in there. Then for the next level, I had 8. Next level after that, I had 6. Then I had 5. Then I had 2. Then I had 1. And then I had 3 on the expensive upper end. And there's my frequency histogram. There's actually something semi-interesting, and if you look at this pattern right here, it was actually the pattern that developed in this chart right here, this tally chart. If I just turn it sideways, you'll see this right here is the same shape that I developed in the frequency histogram. So there's a connection between the frequency table and the frequency histogram. Histogram just shows the tally marks in a more organized fashion. So there's my frequency histogram. Using that, then I can answer some questions about the prices. So instead of using class boundaries, I should mention, before we move on to actually answering questions using the table, you could have also used the midpoint for each class to mark out the horizontal axis, what you would do for that. So instead of doing, like I said, instead of doing the boundaries, the high and the low, you could use the midpoint. So if this class went between 59 to 114, I could designate it by the average, the midpoint. How do you find the midpoint? It's the average, it's the balance. You take the lower class limit, add it to the upper class limit, and divide by 2. It's the same thing as if you were finding like an average test score between two tests. So 59 plus 114 divided by 2 is 86.5. So I could designate this first class by its midpoint, 86.5, whereas back in the original, I didn't do it as its midpoint, I just did it in between its class boundaries. So it just depends on what type of information you're trying to convey. With this picture though, you can then answer some questions. So I'm going to have you try. So if I look at the frequency histogram, the picture shown, the chart, this descriptive statistics, I'd like you to use it to describe, using a complete sentence, where more than half of GPS systems seem to be priced below. So what value are more than half of them below that value? So take a second, pause it, see if you can figure out. You're probably going to have to count up how many there are, and then come back to see how you did. Okay, so first thing you might want to do is tally them up, and when you tally them up, you'll see, well, we had the 30 because there were 30 in there. If I look, halfway to 30 would be 15, 5 and 8 makes 13, and 6 makes 19. So right here, there are already 19 of the 30 accounted for. So using the chart, I would probably say you can see that more than half of the GPS navigators are priced below 226.5, so $226.50. So that's the benefit of using a frequency histogram, is you can easily answer questions like that. Maybe if you want to be competitive, you might want to be below that price point because more than half of them in the market are below that price point. Besides using frequency counts, the actual number, I can also use what's called a relative frequency histogram. It essentially changes your count numbers to be percentages. So it has the same exact shape, it's just been scaled. Your y-axis has been scaled. So the horizontal scale doesn't change, just as your y-axis changes. The vertical scale measures what we call the relative frequencies, not the count frequencies. So we represent it as a percentage. So in order to do that, I take my counts and I'm just going to divide it by the total. So for example, in this first class, we found there were 5 GPS systems that were between $59 and $114. If I want the relative frequency for that, I'm going to take 5 and divide it by the 30 that were sampled. So that'd be 17%. There were 17% of them that fell in that first class. And for the next one, there were 8 that fell in between $115 and $170. 8 divided by 30 would be 27%. And then you repeat this, taking the original count, dividing it by the total to get all the percentages. So we've got 17%, 27%. This would be 20%, 17%, 7%, 3%, and 10%. Be aware, it should add up to 1. Ours adds up to 1.01 due to some rounding, but if you were more precise, went out to more decimal places and rounded more accurately, you would get exactly 100%. So we rounded to the nearest tenth, and sometimes that can lead to one where you're just a little bit above or just a little bit below, but are within the ballpark. Once you've done that, you converted all of your counts into their percentages. You can then rescale it. So all that changes here are the percentages here. So this is now not counts, but percent that occurred. I can use that then to answer some questions pretty quickly. So from this graph, you can see that exactly 20% of GPS navigators are priced between what two values? Well, I go over to where 20% is, which is right here, and I can see that that corresponds to this bar. So 20% of GPS navigators fall between $170.50 and $226.50. That's the benefit of changing them to percentages. Sometimes it's easier to think about it in terms of percentages instead of saying, oh, I'm a certain amount out of 30. We're between that. Then you kind of in your head need to convert to a percentage. So it just saves a little bit of time, makes it easier for the consumer to read. Another type of chart doesn't get used so often, but in terms of you constructing it, but it'd be better for you to know just how to read them. It's called a cumulative frequency distribution. Sometimes it's known as an ogive. It's a line graph that displays the cumulative frequency, so cumulative meaning the sum of all prior parts, of each class as its upper class boundary. The upper boundaries are marked on the horizontal axis. The cumulative frequencies are marked on the vertical axis. Like I said, we won't construct these much at all, but you should be able to interpret them as an informed consumer. So we'll look at an example. Here's an example of a cumulative frequency graph. I'm going to use it to see how many GPS units are sold for $282.50 or less. Well, first off, let's look at this. So down here I start and I'm at 0. So there was 0 that sold for $58.50 because the lowest was $59. And I work my way up and I see the last one is here at nearly $450. It was $450, that was our highest, and that'd be 30, which means this point, just to make sure you understand how the graph works, what it means is that all 30, there were 30 of the units that sold for $450 or less, because it's a cumulative aspect. So for example, in the first one it says how many GPS units sold for $282.50 or less. So if I go to that one, that'd be right here. And it's a little difficult to read my scale because I'm going to estimate a little bit, but this looks just shy of 25, which leads me to believe it's probably 24. So I would say there are probably 24 units that sold for $282.50 or less. Second question, how many units sold for more than $394.50? So that is this one right here. Again, going to have to estimate just a little, but it looks to be just shy of halfway between 25 and 30, which leads me to believe it's probably 27. So if I think about this, 27 of them sold for that value or less, which means there were 30 in total. So 30 minus 27 tells me that there were going to be 3 units that sold for more than $394.50. Last question, the 5 cheapest units are sold for at most how much? So if I go over here and say, okay, the 5 cheapest units are being sold for $114.50 or less. $114.50 is the most amount that those 5 cheapest units are sold for. So benefits of using a cumulative graph as well. And that is it for this topic. So thank you very much. Have a good day and stay curious.